binomial option pricing. Okay, I will first talk about the idea, then we will go into the actual steps of calculating the option pricing model, right? All right. See, the underlying price is what, like in our example today, we are talking always about ACC. We would say like ACC, like right now is trading at 2,800. From today, after a certain point of time, maybe after 1 month, we will assume ACC can be there in only two states. One is an upstate, other is a downstate. Okay, so that is what binomial means. Only there are always two states. This is the basic assumption for binomial. Like as I said, nowadays people are using time series to calculate this, and they might assume 10 states. Okay, like because of AI, we can do that. But with binomial also, you can get there, but we just have to do multiple steps. And but the basic premise is there are only two states for the underlying at any given interval of time. So that's the first one. Then once you have that underlying prices, what is the option payoff in those two states? What is the option payoff in those two states? We need to know that. And then what is the probability of getting to those two states? Maybe the up move. See, ACC might become 3,000, ACC might also become 2,500. Okay. Now, what is the probability of ACC going to 2,500 or 3,000? Those might not be equal. So you also need to know that probability and then calculate the weighted payoff of that two states back to time zero and then discount it. Okay, this is just the theory part. This is not the actual steps, right? I will talk about the steps. This is just the idea behind binomial option pricing model. Maybe it is easier to understand this visually. So I'm going to give this example of ACC again. So if ACC stock price is 2,800 today, what we are saying is it can either go up or down. Only two things can happen. So it can be either 3,000 or say 2,600. So this is the up move and the down move value. It can be different values. I just gave some random numbers. So 3,000 or 2,600, right? Now the probability of going to 3,000 is given by P. What is the probability of going down? It is 1 minus P because there are only two states. There is no other option. So it is complementary event. So either this or that together, it is the total universe. So P plus 1 minus P will be the total probability of 1. Now from that 3,000, we can again do a multi-stage or binomial model where you can do 100 times also, right? From 3,000, it can be either 3,100 or 2,900, let's say. Again, from 2,600, it can be either 2,900 or it can be 2,400. Oftentimes, what we are going to say is this is an S up move. The spot price has gone up. This is the first stage. And this is my second stage. In the first stage, in the up move, SU, we are again doing another up move. So I'm denoting it as SUU or SU square, however you want to notate it. And the second down move, SUD, will be the same as SDU. That is from the down state in the first stage, if it has an up move, that should be equal to SUD. That is the usual assumption in the binomial pricing. So instead of having 4 states in the second stage, we will only have 3 states. I could have another model where these prices are not the same. I have something like this, right? So in that case, I have 4 outcomes, correct? Yeah. But that is not what we will be doing. We will assume that this node is the same. So these SUD and SDU is going to be the same. This both are going to come up with the same answer. So whether it is an up move and the down move or a down move and the up move, the value will be the same. Following this, I'm teaching the theory. In the examination, they will not ask you for a 2-stage, 3-stage binomial. That is beyond your ability to calculate using calculator. You need an Excel. But For our understanding, you need to know this. See, then we can again have, yes, you like it can go multiple stages, but hopefully you are able to visualize how it will move back. So once you have these values, you can find out the payoff in each state and then come back. So this will be another probability P1, 1 minus P1. You can come back and find the value here. You will get another value here. You can again do this and reverse engineer and get to the option price at the beginning. Okay. So we are going to come back and find the values at each of the nodes, and then we will find the value at today's price by discounting it. That is the theory. Like for our exam, you just need to know this theory. You will not do multi-stage option binomial tree. You will only do single stage. So very simple for single stage. The calculation process, I'm going to explain step by step. You just need to follow it. There are 4 steps that you have to do. This part is just the idea behind option pricing using binomial trees. Okay. You just need to know the theory here. Don't worry, they will not give you a 2-stage model. However, like if you are doing this at your workplace, you will do probably a 40, 50, 60, 100 stage model also, right? But that is being done using Python or some programming language. Now let's go to the steps. The first step, you need to know what is the size of the up move. I said ACC will go to 3,000 or 2,600. How did I come up with? You need to first figure that out. What is the up move? What is the up state? What is the price of the underlying? The down state, what is the price of the underlying? You need to know that to do any calculation, right? First step, figure that out. Then, what is the probability? Once you have the up move and the down move, what is the probability of that up move and the probability of the down move? First thing is to do this part. This up move, down move is the first thing. Even in step 1, there is a sequence. First, figure out the up move and the down move, and then calculate the probability. First step. Second step is always good idea to draw the binomial tree and calculate the payoff. I see a lot of students don't want to draw the tree. They just do the formula and then they try to do it. It's fine if you are an expert, but like for our level 1, draw the binomial tree and then put the numbers in and calculate the payoff. So calculate the payoff at all the nodes. Because it's a one stage, there's only one node. Okay, so we are only going to do one stage. So there is only one node. From the parent node, there's like 2 outcomes, 2 child. That's the second step. Draw the binomial tree. Third step is to multiply the payoffs with the probability in each stage. See, what we had, the up move, down move is what? That is the stock price, the underlying price, stock price. Now, based on that stock price, you need to calculate the payoff. That is the options payoff, whether it's a call or put option. What is the payoff? And then apply the probability. Don't apply the probability on the underlying price. There's no point. You have to figure out the payoff and then apply the probability to determine the expected value of the option for the whole period. Third step is that expected value of option is what we are figuring out. Fourth step is to discount this expected value to time period 0 at the risk-free rate to get at today's value. Please write down these 4 steps. Please write. The fourth step is just a simple discounting. Okay, whatever you have calculated as the expected value at time period 1, because it's a one-stage model, you will bring it to time period 0. Discounting. Don't forget the discounting. Again, it's a simple mistake. In the option, you will have an answer from whatever is the third step answer. That is usually an answer in one of the choices. And then like the B would be a discounted value. And you see the answer in A, you might say, okay, I've got the right answer. Both in FRM and CFA, these people do that. And to solve the problem, we need to know some formulas. Notations and formulas we need to know. First one is the probability of the up move. Probability of the up move. risk neutral probability of up move is denoted as pi u. Pi u, right? Pi d is the risk neutral probability of down move. Together, we said the probability is 1, right? So this is in our previous steps, we had denoted as P and 1 minus P. But there is a formula to calculate the probability, and this is not a continuous distribution. It is a discrete distribution formula. So we are denoting it as pi u. Don't worry about what is this continuous and discrete now. For our examination, it is all going to be discrete only. We are not going to do a continuous distribution function. So we are going to use the risk neutral probability of up move, risk neutral probability of down move. So it's pi u plus pi d is equal to 1. Then RF is going to be your risk-free rate, the notation. And u is the size of up move. And d is the size of down move. Okay, so up move and down move. We are going to see a formula for up move. Well, no, I mean, in level 1, they are going to give you the up move, rather, I'm sorry. In level 1, they are going to give you one of the value up move or down move, and the other one is just an inverse function. Okay, you just have to take the inverse of that. So if they have given you an up move, then the down move will be 1 by u. So in your calculator, just put the value and press 1 by x. That's all you have to do. No other formula required. So they will give you one of that up move or down move. The other one is going to be an inverse of that. Okay, if Nifty has a probability of moving up by 20%, so this is how they will say, okay, this is how they say, then your U is going to be 1.2, okay, and your D will be 1 by U, which is 0.833. That's your U, then you just take an inverse, you get your D 0.833, right? Simple. So it's not a difficult step. This is the first thing you will do. Remember, go back to your steps, 4 steps. In that, the first one is to calculate the up move and down move. Without that, you cannot do anything else. So we need to know these values. What is the up move in the next state? Right? Up state and down state, what is the value? Right? Any doubts? You will be given. Any one value has to be given. See, in level 1, we cannot do a time series and figure out that. That should be by itself a separate problem. So they will not ask you to calculate you. Yeah.
It is coming down by 20%, but that the D will be 0.8, right? This is the first thing. If they say it's coming down by 20%, then the D will be 0.8, right?
Correct. And then so you'll do 1 by 0.8, so it will be 1.2 something, right? It'll 1.25, I think, right? So yeah, if in case like if I had given it as 25%, or if probability of coming down is 20%, then your up move will be 25%. They answer your question. What is the probability of the up move, right? What is the probability of the up move and what is the probability of the down move? So probability of up move is given by this formula, okay? Like just you have to remember this. 1 plus risk-free rate minus the down move divided by up move minus down move. This formula is important, very important. Without this, we cannot do binomial pricing. Up move probability, remember, is a risk-free. So this is based on the risk-neutral probability. So you're using the risk-free rate here. 1 plus RF minus D divided by U minus D. Once you have the up move probability, you can just subtract that from 1 to get your down move probability, right? So totally it is 1. So you know the up move probability, you subtract it from 1, you get your down move probability. This part is, if you're done till here, you're done with step 1, right? So all of this, what we have done so far, will finish your step 1 in binomial option pricing. So this is the first thing, determine the size and the probabilities of the up move and down move. We have finished that part. Now we have to draw the binomial tree and calculate the payoff at all the nodes. Then multiply the payoff to find the probability to find the expected value. Then discount it back to today's time. Let's do this for one. We will start with So current price of a stock is $60. Size of up move is 40% and risk-free rate is 7%. Strike price of call is $60. Maturity is 1 year. Determine the current value of the option. So let's do this together. I will do this one and I will give you a problem, but like let's do this as in together. Like I will solve it, but you also calculate it together and make sure you are following. If you have any doubts, let me know. We are going to start with the up move, down move calculation. Down move is 1 by u. Up move is already given, right? Up move is 40% from current level. So that means my up move is 1 plus 0.4, 1.4. Make it all in decimals. Don't use percentages here. Up move is 1.4. This down move is 1 by u. So 1 by 1.4, which is 0.714. Do the calculation. Make sure you're also getting the same answer. So this is my step 1. Calculate the up move and the down move. Then calculate, once you have the up move, down move, calculate the probability of up move using the risk neutral probability formula, 1 plus RF minus D divided by U minus D. Substitute the values 1.07 minus 0.714 divided by 1.4 minus 0.714. This you have to do. There is no shortcut. You have to know the formula. You have to substitute it and calculate the risk neutral probability. What is the answer for risk neutral probability? Very good. 0.519. Wait. I think I got 0.519 last time. Yeah. Try not to round it off in this one. Try to have all the decimals. Okay, because the probabilities are going to be very little different between up move and down move. Sometimes it will be 0.5054 and then it will be 0.4946. It will be like that. It's not going to be big difference up move and down move. So the more decimals I might have rounded off here, but the more decimals you are stored, when you're using the calculator, you can store it. So then you will have the entire value. So if you do that, you're going to get something like 0.518 or 0.519, somewhere around that. I think I have rounded it. I think I got 0.5190. Are you getting the same answers? 518 you're getting. Whatever is the answer, the maximum decimal, store it. Okay. Then your probability of down move is going to be 0.481, that is 0.482 or 0.481. Subtract the up move probability from 1, you'll get your down move probability. Okay, so now we are done with step 1. Very nice. Second step is what? We have to draw the binomial tree, right? Please do that. 60 is the underlying, the up. This is our state of up move and state of down move. State of up move, it is going to be 84 rupees. And state of down move, it is 42.6. I might be rounding off here a little bit just to make the numbers easy to write. But in your exam, you don't want to round off. So in the up move state, the stock is going to be 84. And in the down move state, the stock is going to be $42.66. And we now know the probabilities as well. I have the probability as 0.519 for up move. And for the down move, I have it as 4.810. You might have a slightly different number. It's fine. Now, should I apply this probability on those 84 and 42.6? Is that what we said? Should I multiply 84 into 0.5190? Should I? No, that is not what we said. We have to calculate the payoff and then multiply, right? Don't make that mistake. A lot of people do this. They just multiply the probability with the stock price. Okay, that is not what we are going to do. We are going to calculate the payoff first. So this is a call option. So the payoff is ST minus X. ST is 84, X is 60. We said the strike price is 60. If my spot is 84, my payoff is 24. This is at ST is equal to 84 up move and ST is equal to 42.6. If my spot is less than my strike, it is going to be a max function of 0, comma st minus x, correct? And so the down move payoff will be 0, right? That makes our calculation easier. There's no calculation on the downside. So what is the expected payoff? Now you apply the probability on the payoff to calculate the expected payoff. Your 0.519 into 24 and 0.481 into 0. On the downside, it's just 0. So just the upside you have to calculate. What is your expected payoff now? 24 into the probability on the up move plus 0 into probability on the down move. How much? 12. Okay. 12.45. Very nice. So is the option value 12.45? Yes. Yeah, there's a question online. How did we get 24 is the question. How did we get the payoff of 24? For call option, what is the payoff? Max function of 0, comma st minus x. If the spot price is 84 and my strike price, so in the question we have given the strike as 60, strike price is 60. That means x is 60, right? So the payoff is st minus x on the max side. The lower side, the lower bound is going to be 0 payoff. St minus x, st is 84 minus 0, strike of 60. So my payoff is $24. Yes. Understand? So that is how we got 24. And for this side, the downside, this one is going to be, st is going to be 42 minus 60, which will be minus 17.4, right? Will we get minus 17.4? No, we will not exercise it. We will say, I will walk away from this option. So my payoff will be 0. Okay. All right. So expected payoff is 12.45. Is this the option price? No, it is not the option price. Don't stop here. This is what I was saying. You have to discount this price. Discount it to today's value. Fourth step. Fourth step is discounting. Don't stop here. The option value is the discounted value of the expected payoff in the future. This is in the future. So you're buying the option today. So I need to discount it by the risk-free rate. Risk-free rate I had given as 7%. So the option value will be 11.64. So that is a binomial option pricing model. See, in the examination, this will take a lot of time. In FRM, there is more time. In CFA level 1, you have only 1.5 minutes, right? So at least in FRM, you have 4 minutes for each question. So in CFA level 1, I don't think they will ask you to solve the entire thing. They will give you some of these values in between, or they might ask you for one step. What is the probability of up move? Something like that. So it's not going to be a full calculation, given that you only have 90 seconds. For you to read the question will take 30 seconds. So you will literally have only a minute to solve. Okay, shall I give you a problem now? Do you have any questions from the one that we looked at? Any doubts here from this problem? Good. I'm going to give you a put option pricing. But note down, if you have not noted down, please note down. For your problem, let's go with Apple. Apple is now trading at $180 per share. You buy a put. So Apple has been coming down, right? You guys watching? You buy a put. So you think it will continue. You buy a put option with a strike of 185. Okay. Risk-free rate, Federal Reserve SOFR rate is 3%. Apple share price I gave you, risk-free rate I gave you. The probability the up move is estimated to be 25%. Compute the price of put option with 6 months to expiry. So the put option is expiring 6 months from now. what is the price of the put option? Do step by step. First step is to calculate the up move, down move, then the probabilities. Then draw the binomial tree, then calculate the expected payoff, and then discount it back by 6 months to find the put option price. 4 steps, 4 steps. I'll give you 2 to 3 minutes even. Do it slowly. Then I will start solving. Everyone getting the up move, down move as 1.25 and 0.8. Hopefully that part everyone should have gotten. Now calculate your probability of up move, which is your 1 plus RF minus D divided by U minus T, which is 1.03 minus 0.8 divided by 0.45. 0.51111, something like that. Okay. I'm going to round it to 1 year because just to ease of writing, you don't round it. You should store it in your calculator. And pi d is going to be 1 minus pi u, which is 0.488. That is our step 1. Then the step 2 is to draw the binomial tree. Okay, so starting with, we are having $180 as Apple share price. So my up move would be in the future, 225 is my up state. Down state is 144.511, 0.488. What is the payoff here? For a put option, our strike price was 185, so this is going to be 0. And for this one, it is 185 minus 144, so 41. So expected value, payoff up move multiplied by probability of up move by payoff down move multiplied by probability of down move, 0 into 0.51 plus 41 into 0.488. Which is $20 expected payoff. Did you guys get 19.7? Where are you guys? Maybe I did a little bit ahead of you, but you must have gotten the up move, down move probabilities till that point. You got it. Yes. So once you have the probability, you have to calculate the payoff. It's a put option. Put option means X minus ST, right? X is 185. Strike price is given in the question, right? It's given as 185 is the strike price. That is my X. For put option, the max of 0 or X minus XT. So X minus ST for 225, X is 185 minus 225. So that's a negative number. Will I take a negative payoff with options? No, we will choose 0. We will not exercise this, right? So the up move, I don't even have to worry about it. I will not exercise the option. My payoff is 0. What about the down move? 185 is my strike. And my spot is 144 in the down state. So I am now making a payoff. Now there is a positive payoff of 41. If Apple comes down in the down state, it is going to be $41 is my payoff. But the probability of that happening is 48.8%. So I need to multiply that payoff with the probability to calculate the expected value. 0 into 0.51 plus 41 into 0.488. So if you are getting 20 and then you discount it, you'll get something like 19.7. I have rounded it. If you haven't rounded, you might get slightly different answers. Did everyone get 19.7? Congratulations, this is an achievement. Like, to calculate the option price is not easy. Like, you just did your first option price calculation. See, obviously this is a one stage model. If you want to be more accurate in real life, you will not stop at one stage. You will predict Apple's price from there. So you will do a binomial model where you will have 10, 20, 30, 40 stages. Where you will predict Apple's prices from there, like, and then like up move, down move, up move, down move, and then bring it back. Right? So that is how you will write a program. But we are doing manually. This is just to understand the concept and calculate it. But if you can do for one stage, you can do this for any number of stages. So now if you figure out the option price and then you see the option is trading at a different value, what will you do? Don't go and sell that option because there are a lot of other factors also. This is the very basic way to calculate the option price. Did everyone get this answer? Do you want to solve one more problem or are you guys feeling good? You want to solve one more problem? Simple problem you solve. I will just ask you to calculate the probability of the up move alone. Okay. If discount factor for 1 year is 0.98 and down move size is 0.75. Compute probability of up move A. If expected option value is 24, what is the option price? Okay, discount factor means so this is your 1 by 1 plus R to the power n. That is called as the discount factor. So for first year, 1 year, it will be a 1 year discount factor. If you have not attended fixed income yet, you will not know that. So by 1 plus R is already given to you as 0.98. First, compute the probability of the up move. Second one, they have given you the expected option value. What is the option price? They are not saying whether it's a call or put. You don't need to know because they've already given you the expected option value, which is probability multiplied by payoff. They have done that value. So this is how you will most likely get. They will not ask you an entire option pricing step by step. Find what? You don't need this period. I've already given you the discount factor. That is 1 by. So from there, you can calculate the risk-free rate. 1 by 1 plus R, this is 1 year. So raised to the power 1 is equal to 0.98. So compute R. That is going to be your risk-free rate. I've given the discount factor. Yeah. So let's do that. 1 by 1 plus R, 0.98. So 0.98 R is equal to 0.2. R is equal to 0.2 divided by 0.98. That will be slightly more than 2%, 2.0408. So my risk-free rate is 2.0408%. Yeah, so when you just use 1 by X. So downside is 0.75. In your calculator, you type 1.75 and press 1 by X. So your up move is 1.333.
Now they use the discount the option.
Yeah. Or you can multiply directly with the discount factor. You can just directly multiply it by 0.98. Or you can do discounted using, so it will give you the same answer. They have given you the discount factor. So discount factor multiplied by the future value is equal to your present value. Okay. So what is your pi u? They ask for the probability of up move, which is 1 plus RF minus D divided by U minus D. RF is given as 2.048. So 1.020408 minus 0.75 divided by 1.33 minus 0.75, which is 0.583. If you do this math, what are you getting? 463. Okay. This is the answer to question A. Question B, they have given the expected payoff as 24. So 24 into 0.98, which is 23.52.